Hello friends, today we will see the next part of Unit 1, that is measurement standards and design of gauges. These are the contents of Unit 1. Here we are going to learn today accuracy and precision. These are the terminologies which are used there in measurements. So we are going to learn today the different terminologies which are used there in measurements. So basic terms related to measurements of measuring system are as follows: accuracy, precision, sensitivity, calibration, interchangeability, reproducibility, repeatability, magnification, drift or stability, least count, uncertainty, range or span, and last one is discrimination. So these are various terminologies which are used there in measurement. Let us see one by one. So first of all, we will see the term accuracy. Accuracy, what is meant by accuracy? Accuracy is defined as the maximum amount by which the result differ from a true value. That is, closeness to the true value is called as accuracy. See, we know that the purpose of any measurement is to determine the true dimensions of given part. True dimensions of given part means what? Whatever design values of the components are there, generally those are theoretical values or those are the desirable values. So we call them as true dimensions or true values. But none of the measurement can be absolutely accurate because we don't get always the true dimensions of the part or component. There is always some error while measuring the dimensions. The difference between the true value and measured value, we know that is called as error. So accuracy may be defined as the closeness of a measured value with the true value. Accuracy compares the measured value of a manufactured component with its true value. The true value means the specified value of a component before the start of the production. Means it is generally there on the design drawings or design sheets. So we call them as true value. Measured value is the reading or value obtained after inspecting the actually produced component. Therefore, the accuracy is defined as the closeness of measured value of the component produced with its true value. The act of measurement should indicate the true dimensions of a part, but in actual practice, no measurement can be absolutely accurate. Therefore, there is always some error, and the amount of error or inaccuracy depends upon the various factors. More the error, less will be the accuracy of that measuring instrument or measurement process, and vice versa. Second terminology is precision. Precision has no meaning for only one measurement, but it exists only when the number of measurements are carried out for the same quantity under the identical conditions. So for any set of measurements, the individual results obtained may vary slightly from the mean value. Lesser the variations in the measurements, the more is precision. Therefore, precision is defined as the repeatability of the measuring process. For example, if numbers of measurements are carried out for a single quantity in identical conditions, identical condition here means by same observer with the same instrument and within short intervals of time, and all the readings are close to each other as well as the mean value, then the readings are said to be precise. So precision, it is the less variation in the measurement. If there is less variation in the measurement, then the system is called as precise measuring system. If the instrument gives you the readings which vary very less from each other, then we call that instrument as precise instrument also. See, I will give you here one example. The example from the epic Mahabharata, We know that uh, Dronacharya was the guru, or we call it as teacher, for Kauravas and Pandavas. So one day he examined all Kauravas and Pandavas. By taking the uh, examination of all those students, that is Kauravas and Pandavas. So when he was teaching all the students archery, then he told all the students to target at the uh, to concentrate at the target. So for that purpose, he has taken one example. On a tree there was a bird sitting on the branch of that tree. So Dronacharya called each and every student and asked him to target at the bird. But most of the students, means from Kauravas and Pandavas, they told that they are observing different things along with the birds. So they were telling what they were observing, but there was one student of Dronacharya. We know him well, that is Arjuna. So Arjuna told Dronacharya that he was only observing the bird's eye, where Dronacharya has told him to target or concentrate. So if we see, Arjuna was, so we can say that Arjuna was very accurate as well as precise. Hence, he could judge what was exactly the target. But other students, means other than Arjuna, other Kauravas and Pandavas, they were telling the other things also, means bird, tree, branch, and other things. So they were not concentrating at the target. It means among those students, Arjun was the most accurate and precise student. So in the same way, measuring instruments which are there, they also have such properties, that is accuracy and precision. So the instrument which gives us very accurate values, we are going to call it as accurate instrument, and we call its accuracy is higher. Whereas the instrument which gives repeatedly good results or readings, then we call it as precise instrument. So accuracy and precision, these two terms are very important from measuring process point of view. There are some other terminologies also. Let us see accuracy also. Accuracy is how close a measured value to the actual value, whereas precision is how close the measured values to each other and the mean value. So examples of precision and accuracy I have shown here in this diagram. See here, I have shown the circles and their centers, and the center is heated. But first figure, if you see, which tells us low accuracy and high precision, because the value to be targeted, that is the center of the circle, but the target is not the center of the circle here. All the targeted values were different, but all those targeted values are near to each other. That's why first figure gives us low accuracy and high precision. If you see the middle or second figure, then we will see that all the targeted values which are there, or actual values which we have obtained, then those are near to the central value, means target value, but they are scattered one. So this figure shows us high accuracy but low precision. Whereas the last figure, that is third figure, it gives us, see the actual values which are obtained, they're at the mean value, that is the central value of the circles. So it is, and secondly, all those values which are there, those are very close to each other. So this third figure gives us high accuracy and high precision. In this way, accuracy and precision can be understood by using some examples. This is the difference between accuracy and precision. So accuracy is the agreement of the measured value with the true value of measured quantity, whereas the precision is the repeatability of measuring process. It shows how well identically performed measurements agree with each other. Second is accuracy is concerned with the true value, whereas precision is concerned with the mean value. Precision has no concern with the true value. Third is it is difficult and expensive to have good accuracy, whereas it is much easier and cheaper to achieve the precision than to achieve the great accuracy. Fourth point is high accuracy cannot be obtained with low precision, whereas high precision can be obtained with low accuracy. So we will move to next terminologies also. So see here, accuracy and precision already I have defined here. Next is sensitivity. Sensitivity of the measuring instrument, it denotes the smallest change in the measured variable to which the instrument responds. Third, next terminology, that is calibration. The process of framing or checking the scale of the instrument using some standard is called as calibration. So calibration is the important process in say in framing or in the measurement process. The process of framing the scale of the measuring instrument by making use of different standards. You can use different standards such as line standard, N standard, or wavelength standards. So by making use of these standards, you can calibrate the instrument. And one thing is that well calibrated instrument gives us more accurate as well as precise readings. Next one is interchangeability. The ability to interchange various parts of an assembly at the time of assembling. So this interchangeability feature which is there, it is most important because nowadays to cope up with the demand of mass production, the manufactured components should be interchangeable. For example, replacement of mobile or laptop charger of the same company, replacement of the engine parts of the same company, replacement of the gears from the gearbox of the same company or same vehicle. So these are the some of the examples where interchangeability concept can be applied. The next terminology is reproducibility. It is the quantitative measure of the closeness of the agreement between the results of measurement of same parameter carried out by changing the method of measurement, operator, instrument, and other conditions. So this is in simple words the instrument or the measuring system or process, whether it is going to reproduce the same or more or less same set of readings under the given conditions or not. So that characteristic is called as reproducibility. The next one is magnification. The system or arrangement of the instrument to increase or magnify output so that the instrument is more readable. We know that some of the instruments, they give us the readings whenever they are going to measure a quantity. Whatever output signal is produced, it is very weak. That output signal, if it is very weak, then it cannot be observed or it cannot be sensed by the measuring instrument. So in order to sense it and in order to be more visible, that signal should be magnified. So whatever system which we apply for magnifying that signal so that it is readable, that process is nothing but the magnification process. Then drift or stability. So it is the ability of an instrument to retain its performance or calibration throughout is specified operating life. Means during the life of the instrument should retain its performance. It should give always a better performance, or it should retain its calibration so that it should give the more accurate as well as precise readings. So this characteristic of instrument is called as drift or stability. Then resolution, that is least count. The least count of any instrument is taken as the resolution of the instrument. The smallest reading measured by an instrument is called as the resolution of that instrument, or it is also called as the least count of that instrument. The next point is uncertainty of the instrument. It is that part of the result of measurement which states the range of values within which the true value is estimated to lie. See here, uncertainty of measurement or uncertainty of measuring instrument. We know that the instruments always give slightly different values from the measured quantity with the repeated instruments. The uncertainty of measuring instrument or measurement is that part of the result of measurement which states the range of the values within which the true value is estimated to lie. It denotes the degree of accuracy with which the measurement has been made. So it is always difficult to find the true value of the quantity to be measured. Hence, instead of specifying the measurement error, the range of error is specified, and that range of error which we specify, that is called as uncertainty of that instrument. Suppose, for example, suppose a ring is there and a ring is having a diameter of say 40 plus minus 0.5 mm, then it means that the diameter has a nominal value of 40 mm and it is going to vary in between plus minus zero point 0.5 mm uncertainty, that is 40 plus minus 0.5 mm, that is say 39.5 mm and 40.5 mm. So this plus minus 0.5 mm value is known as uncertainty in that measurement. The next is range or span. The minimum and maximum values of a quantity for which an instrument is designed to measure is called as range or the span of that measuring instrument. So the instrument has limitations. Generally the range, it can start from 0 up to 100, it can go beyond 100. So what are those values which are specified for a measuring instrument, uh, between means I will say that maximum limits and minimum limits of the quantity to be measured, those will vary in between these maximum and minimum values. So that total maximum and minimum values of a quantity will represent the range of that measuring instrument or measurement process. The last terminology is discrimination. Discrimination is the ability of measuring instrument to react or to respond to small changes of the measuring quantity. So if measuring quantity is going to change by very small amounts, then it is the ability of the instrument to respond to such small changes of the measuring quantity. If the instrument is responding in a well manner to such small changes of measuring quantity, then we can say that that instrument is having good discrimination parameters. If it is not responding or if it is responding in a slower way, then we can say that that instrument is having less discrimination. So these are various terminologies which are used there in the measurement. So these are some reference books, references which I have used. So I hope you have understood these terminologies. So we will stop here today. Thank you.